Now I'd like to add a little bit more detail. So we'll do another example at the same time so you can see this happening with something else. So I've got the same kind of setup, all right, but now I've got lead bromide and it's liquid, so you have to melt it. It wouldn't be a liquid at room temperature, it'll be a solid salt, but we heat it up until it melts, and we then have in here, remember this is not a solution, there's no water in here, this is just pure liquid lead bromide. We're going to have our Pb2+ lead ions, and we're going to have our Br- bromide ions. Now I'll draw two of those because it is in the ratio of 1 to 2. However, you have to remember they're going to be quite a lot of these ions in the liquid. Now remember, this is the positive end, this is the negative end, so this is the negative electrode and this is the positive electrode. Now you'll be glad to know that chemists have given each electrode a special name. So the negative electrode is called the cathode, and the positive electrode is called the anode. All right. Then there is obviously a nice mnemonic to remember this, which is panic, which stands for positive is anode, negative is cathode. Okay, so right, so we turn the battery on and the electrons start flowing. So what happens is my lead ion is attracted over to my cathode and my bromide ions are attracted to the anode. Okay, and it's nice to remember that this metal ion here, if you remember, a positive metal ion has a name which is a cation. So you can see that the cation is attracted towards the cathode, and these negative non-metal ions, these negative ions, these are called anions, and you can see that the anion is attracted towards the anode. All right, so that's another way of being able to remember it, which one's which. So now we just need to think about what's happening at each electrode. So we can go with the cathode first. At the cathode, what do we have happening? Well, my lead ion is going towards there, so it's Pb2+, and that's going to turn into Pb by gaining the electrons that are on the cathode. And so it's going to need to gain two of those. And then at the anode, we have my Br-. Now Br- is going to form Br, but remember this is a group 7 element, so it's going to be Br2. So I need two of those. And it's going to do that by, remember, for the electrons to flow through the rest of the circuit, it needs to get the electron from the bromide ion, give it to the anode so that it can then go into the circuit. Like that. Okay? So if we wanted to think about it, we could think about it a little bit like this. So at the cathode, what's happening is we've got our Pb2+, okay, and the electrons are going onto the Pb2+, like that. Okay, so the lead ion is gaining the 2 electrons. It's gaining these 2 electrons. And at the cathode, the opposite thing is happening. So up here, sorry, at the anode, the opposite thing is happening. So the anode, we have the Br minus, okay, and that's giving its electron to the electrode. All right, so you can see that electrons are coming out of the circuit here and then into the circuit here. I mean, it's all part of the circuit, really. So they're coming off the electrode and then going back onto this electrode here through these 2 processes. Now, it's also important to notice that because this is a liquid, all right, for lead bromide to melt, when you make the lead is also going to be in the liquid state. However, bromine, this is going to be produced as a gas. Okay, so you would expect to see at the anode a gas being produced. And if we go back to the example we did in the last one, okay, the chlorine, this would be produced as a gas as well. Okay, and there is a test that we can do for that. And the test for that is that if you take a piece of damp blue litmus paper, okay, so Cl2 gas will bleach damp blue litmus paper. And when I say bleach, what I mean it will remove the colour from it. Okay, so whenever we talk about bleaching something, okay, we just mean remove the colour. All right, and there's a picture in the book that you can see that happening. So here you can see we've got this piece of litmus paper, we've dampened it, and we're now holding it over a jar of chlorine water. We haven't dipped it into the chlorine water, but obviously some chlorine is going to evaporate off here, and then as it gets to the damp blue litmus paper, it bleaches it white. All right, and that's the test for chlorine gas. So what that means is, if you were doing this electrolysis experiment, okay, we will do this electrolysis experiment, not this exact one, we'll do it in a slightly different way. So if you were to have here, this is your damp blue litmus paper. All right. What happens is, because Cl minus is coming up here, and this reaction here is happening, this one down at the bottom, which produces Cl2, okay, we get chlorine gas coming off. Okay, so this is Cl2 gas, and that will bleach the colour out of that. So it removes the colour from the damp litmus paper. Okay, and that is a test so that you know that this is happening. We'll do an experiment similar to this one, like I said, not this exact one, and you'll be able to see the damp litmus paper change colour. You'll also notice that the classroom will start to smell like a swimming pool, and that's because chlorine is what they use to disinfect the water in swimming pools. So obviously the day we do that, we'll have to have all the windows open, but you'll still notice that really strong smell of chlorine. Okay, so from this video, there's lots of things that you need to remember. Okay, so you need to remember this test for chlorine gas. So you might want to put that onto a flashcard. Okay, that's how you test for chlorine gas. Other things that you need to remember are the positive electrode is called the anode, and the negative electrode is called the cathode. Okay, you need to remember that. And it's also worth remembering that at the cathode, we are gaining electrons. all right? And so the gain of electrons is reduction. And at the anode, we are losing electrons, and the loss of electrons is oxidation. So you will always get reduction at the cathode, oxidation at the anode. Okay, so what you need to do is you need to make sure you've got all these notes in your book. I know there wasn't a lot of questions for me to ask. Sorry about that. But there's a lot of information that you can go back through it, and then you want to get all the really important points, get some flashcards or start memorizing those pieces of information. Okay, good work.